Hello, let us see part D. Now part D, we are going to apply a factor formula on these two. So we shall now find, let me first rearrange, this is sine 5 theta, then plus sine theta minus 2 sine 3 theta. So with this, now I can apply the factor formula on these two terms. This is going to be 2 sine cos. Sine, when we have added now these angles, we get 6 theta, then divided by 2. Then cos, when we subtract the angles, which is 4 theta divided by 2, then minus 2 sine 3 theta. So this gives us a 2 sine 3 theta cos 2 theta minus 2 sine 3 theta. So after that, we can now see that we have a 2 sine 3 theta common. So I get 2 sine 3 theta. And now I be getting a cos 2 theta here and minus 1 here. So now from that, let us see. Now we have this triple angle, we don't need it. We know that sine 3 theta is the same as 3 sine theta minus 4 sine cubed theta. So if we factorize sine out, we shall get 3 minus 4 sine squared theta. So back here we are going to have a 2 sine theta, and you now see we have it here, then times this 3 minus 4 sine squared theta, that bracket, and another bracket of course 2 theta minus 1. Okay, so let us see. Now so far I have 3 brackets, but I want to observe that we have already obtained this 2 sine theta and 2 sine theta here, and there is a cos 2 theta here, but there is this bracket here. Let us first work on this bracket. You should know that sine squared of an angle is the same as 1 minus cos, we double the angle, then you divide it by 2, which implies that our sine squared theta here is going to be 1 minus cos 2 theta divided by 2. So if we put a negative 4 on both sides, we are going to have, let us see, 2 sine theta, then this bracket here where there is a 3. Now negative 2 sine squared, what are we going to have? This is negative 2 times 1, so we shall have a negative 2, then this is going to be a plus 2 cos 2 theta, and the other bracket is cos 2 theta minus 1. Hope you have seen how I've manipulated this part here. It was sine squared theta, and I had to transform it 1 minus cos 2 theta over 2, but now since it is a negative 4, I multiply a negative 4 on it. It gives me a negative 2 here, and when I multiply negative 2 on this bracket here, I'll be getting negative 2, then plus, because this negative and negative, so this is what we get. Alright, so let us move on until we prove our identity here. So in this bracket we shall have 2 sine theta. In this bracket we are going to have 1 plus 2 cos 2 theta, then times cos 2 theta minus 1. So from here I'm going to multiply so let us multiply these two brackets. So here we shall have 2 sine theta. So 1 times cos 2 theta, we get cos 2 theta. 1 times negative 1, we get a negative 1. Then we come to this 2 cos 2 theta times cos 2 theta, we get a plus 2 cos squared 2 theta. And now 2 cos 2 theta times negative 1, we get negative 2 cos 2 theta. This is 2 sine theta. So now we are seeing here we have a negative, we have cos 2 theta and negative 2 cos 2 theta. So this gives us a negative cos 2 theta, then plus 2 cos squared 2 theta, and now we shall be having a minus 1 here. Alright, so now you should note that cos squared theta, let me use another angle. Cos squared of any angle is the same as 1 plus cos twice that angle divided by 2. You need to note this. So from that, let us see. Now I'm going to use this to get rid of this cos squared. So how? So when you look at this, this is 2 sine theta, then inside the bracket I have negative cos 2 theta plus a 2, but now we have a cos squared 2 theta, and I said the cos squared of an angle is 1 plus cos twice that angle divided by 2. So but our angle is 2 theta, so we shall be having 1 plus cos 4 theta, then over 2, and a minus 1 finally. So this is going to be 2 sine theta, then minus cos 2 theta. Now this 2 cancels this 2, so we shall be having 1 plus 1 plus cos 4 theta, then minus 1. And now this 1 cancels, this cancels this. So finally we have got our proof, which is now going to give us a 2 sine theta so we have cos 4 theta minus cos 2 theta. Wow, it wasn't easy proof. You need to have so many manipulation until you get it. So we can see now that the left hand side is equal to the right hand side. Thank you for watching. I am teacher John Isaac. Please subscribe my channel and recommend the channel to your colleagues who are doing pure mathematics. So this is the factor formula. We shall meet it again during the topic of integration. It may be available on this platform, so you need to check my playlist and see if you have that. We have that trigonometry, and you practice it. You will find this factor formula once again. Alright, so have a nice time.